Okay, I came across this paper on Nature published this month, and I thought it was very interesting for those who are involved in generator protection. So what the paper mentions is that there's a gap addressing a specific situation whereby the 87G, the generator differential protection, cannot address the internal stator fault. Nothing else is really designed to catch it. You've got voltage control over current, negative phase sequence, dedicated backup stator protection, which is you have some legacy relays. I think of the PVMM that was manufactured in Chennai. But a dedicated backup doesn't exist. Backups that are here mentioned in the slide doesn't really address correlation between phases. Okay, and that's the blind spot. Stator interturn fault can break phase symmetry well before any magnitude threshold get triggered. The conventional backup functions are not properly designed for these signals. So this paper proposes a backup method using alienation indices derived from Pearson correlation coefficients. So for primary differential relays, stator protection, when these fails due to CT saturation, relay malfunction, or communication failures, there are no dedicated backup scheme that exists for the stator windings. So this paper proposes a backup method using alienation indices derived from Pearson correlation coefficients of three-phase voltage and current measurements. So the principle mentioned in the paper is called fault break correlation. So in a healthy generator, phases maintain perfect Pearson correlation. So as soon as there's a faults within the windings of the stator, that correlation just breaks. So that's the Pearson's method. So the Pearson's method just bases its algorithm in 15 indices, is pure correlation math, no frequency transform, no signal decomposition. So these indices are computed from the voltage and the current sampled at a 2.5 kilohertz via standard instrument transformers. So the paper mentions that they have tested this principle on a motor generator set and coordination with the main protection just to ensure that there's no issues of coordination. So here it mentions that despite testing under extreme conditions, including CT saturation and simultaneous multi-phase faults, the proposed scheme achieves security and dependability exceeding 99.8% with a total malfunction rate of only 0.37%. Correctly identified fault events in 99.63% of the 2,465 test cases. The alienation algorithm simplicity, effectiveness, and reliability outperform existing coherence-based approaches in response speed, accuracy, and robustness to instrument transformer errors. Okay, the paper is open access. I'll leave the link on the comments. Let me know your comments on what you think about this paper. I thought it was interesting to share it. It's an interesting concept.